restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps.
Each side of the crack, instead of us visiting once every day or once.
Beneath the towering peaks and awe-inspiring geysers of Yellowstone National Park, a mystery is unfolding. In a sudden and alarming turn of events, a massive crack has appeared in the earth, stretching an unbelievable 100 feet wide. The cause of this unsettling phenomenon is unknown, and visitors to the park are left wondering what this could mean for the beloved attraction. Could this crack be a sign of impending danger? Is Yellowstone in jeopardy? Let's uncover the truth behind this bizarre occurrence. Yellowstone National Park is a place of true wonder and awe, with something for everyone to enjoy. Among the park's many treasures is the breathtaking Grand Canyon, carved over time by the mighty Yellowstone River. The lower falls, a jaw-dropping 308-foot plunge, creates a mesmerizing spectacle that rivals even the mighty Niagara Falls. The emerald green moss and algae growing along the river's edge make for a stunning contrast against the clear rushing waters. The Mammoth Hot Spring, with its stunning terraces and travertine formations, is another incredible sight to behold, a product of the heat, water, minerals, and limestone that are abundant in the area. But Yellowstone is not all beauty and tranquility. The Mud Volcano area provides an eerie and captivating glimpse into the destructive power of sulfuric acid eating away at the landscape and hissing ominously. And for those seeking some fiery excitement, the Upper Geyser Basin is home to the iconic Old Faithful Geyser, with its predictable and thrilling eruptions. Yet beneath the surface, there lies a potent reminder of the volatile power of nature, the looming presence of a volcano, a constant reminder of the park's explosive origins. However, a new and unsettling phenomenon is taking place in Yellowstone, and it's causing quite a stir. Within a mere 24 hours, a massive crack spanning 100 feet appeared, forcing park authorities to seal off a large area for urgent investigations. The crack was found in Teton, an area of the park known for its association with volcanoes. The geological processes that gave rise to the jagged peaks of the Teton Range are fascinating and complex, but one thing is certain: steep cliffs and walls are particularly vulnerable to the forces of nature. The rocks that make up the Teton Range are some of the toughest, most resilient, and least porous rocks known to man, and their resistance to erosion has allowed them to preserve their towering heights for millions of years. Nonetheless, erosion is a never-ending battle, and the steep slopes bear witness to the unrelenting assault of natural forces. The Tetons may seem like a static wonder, but the reality is that daily and annual temperature changes cause constant stress and strain on the rock particles, leading to tiny contractions and expansions. Eventually, even the densest rocks yield and cracks form. Water seeping in along the surface of weakness freezes and expands, prying a slab of rock away from the mountain wall. This process is known as frost wedging, causing the slab to eventually tip and fall. The rocks that fall can travel hundreds and even thousands of feet down the mountain slope, with pieces breaking off along the way. Gravity then moves the debris, sometimes in slow flows like a glacier, or in the thunderous roar of a snow avalanche. The result is a constantly changing landscape, with trees, bushes, and soil swept away, and new rock surfaces exposed to water and frost. The scars left behind by these natural forces are a testament to the incredible power of nature. Running water is another powerful force that has played a significant role in shaping the Teton Range. We all know how a broken water main can cause significant damage, but imagine the destructive force of a flood. Spring floods in the Tetons are known to carry up to 5 feet of water, causing rock debris to flow onto the valley floor. Therefore, the recent discovery of expanding cracks in the rock buttress at Teton is a cause for concern. Geologists are closely monitoring the area for any signs of movement. Meanwhile, Yellowstone National Park is also undergoing changes as its magma chambers fill up with the molten rock from deep within the Earth's mantle. Just last month, scientists developed a new method to estimate the amount of magma entering the supervolcano during the recharging process. Although it can't predict an eruption, this technique may help experts understand how the deadly magma store is replenished. Washington State University researchers have found that pools of molten volcanic rock formed in subsurface magma chambers play a crucial role in the eruption process. Professor Peter Larson, a co-author of the study, compared the process to heating up a boiler, explaining that the chambers must be filled before an eruption can occur. When the chambers rupture, up to 240 cubic miles, or 1,000 cubic kilometers of magma can be released into the atmosphere. The volcanic rock rhyolite, which is rich in silica and is a key driver of a volcano's destructive power, is heated from below by the plume of magma, according to Professor Larson and his colleagues. They injected a safe radioactive isotope into hot springs at Yellowstone National Park to measure the amount of water and heat flowing out of the hydrothermal vents, which play a significant role in the Yellowstone volcanic system. The amount of water flowing through the springs and the amount of heat leaving them was previously underestimated in previous studies, the researchers found. As we ponder the possibility of a Yellowstone eruption, we might wonder if we can prevent it or if we're doomed to be helpless bystanders. Well, NASA has come up with a pricey but feasible solution. By drilling 6 miles deep into the supervolcano and pumping in high-pressure water, the volcano could be cooled. The upside? The heat produced during the process could be utilized to generate electricity at incredibly low prices. However, this plan is not without risks. Drilling into the top of the magma chamber is precarious and could result in a worse eruption than the one we're trying to prevent. But if we drill from lower sites, we might have a better chance. There is also the issue of the painstakingly slow process of cooling, which would take tens of thousands of years, and even then, success isn't guaranteed for hundreds, if not thousands of years. It's a gamble, but it might be worth it. Now let's take a moment to consider what would happen if NASA's plan to prevent a Yellowstone eruption fails. If the supervolcano located beneath Yellowstone National Park were to erupt, the consequences would be dire. It could scatter ash thousands of miles across the nation, causing extensive damage to buildings, crops, and power plants. This would be nothing short of catastrophic. Yellowstone's famous geysers and hot springs are due to a 5-mile deep reservoir of hot magma fed by molten rock originating hundreds of miles below. As the magma rises and cools, the ground above it regularly rises and falls. The park's history includes several eruptions, with the most recent occurring 70,000 years ago at Pitchstone Plateau, and most of these have been relatively small. But the idea of a catastrophic supereruption is what has everyone's attention. A supereruption is defined as anything that rates an 8 or higher on the Volcano Explosivity Index, ejecting at least 1,000 cubic kilometers or 240 cubic miles of material. That's enough material to bury the state of Texas 5 feet deep. These types of eruptions are thousands of times more powerful than even the most significant eruptions recorded in history, including Mount St. Helens in 1980. Yellowstone has had 3 of these massive eruptions: 2.1 million years ago, 1.3 million years ago, and 664,000 years ago, which led to the formation of the Yellowstone Caldera, a 34-mile by 50-mile depression in the ground. Imagine a catastrophic event that could change the course of history, a supereruption. If this were to happen at Yellowstone National Park, we would notice intense seismic activity signaling the eruption is imminent. But what exactly does a supereruption entail? It's a volcanic explosion so massive that it's 1,000 times more powerful than a regular eruption. The lava flows would be contained within the park, but the aftermath would be devastating. Volcanic ash made up of splintered rock and glass would be ejected miles into the air and spread across the country, causing widespread damage. Though only 1/3 of the material would reach the atmosphere, the impact would be felt by all. It's a bleak scenario, but one we must consider to be prepared for the worst. Scientists have used both historical records and advanced technology to determine that a supereruption at Yellowstone could produce a massive cloud that spreads in all directions like an umbrella. If this were to happen, the northern Rockies could be buried under 3 feet of ash, causing devastation in Wyoming, Idaho, Colorado, Montana, and Utah. The Midwest would receive a few inches of ash, while the coasts would receive less. The precise distribution would depend on the season and weather conditions, but any scenario would be disastrous. Volcanic ash has the potential to kill people, plants, and animals, as well as crush buildings. Even a few inches of ash can destroy farms, clog roads, cause respiratory issues, block power lines, and short out transformers. The impact of such an eruption would be felt throughout the continent, forcing much of North America's air travel to a standstill. A supervolcanic eruption in Yellowstone would not only have devastating consequences locally, but would also impact the global climate. When volcanoes erupt, they release sulfur aerosols into the atmosphere that reflect sunlight, thus cooling the planet. Minor eruptions like Mount Pinatubo in 1991 resulted in a temperature drop of about 1 degree Celsius that lasted for several years, while the Tambora eruption in 1815 caused enough cooling to damage crops worldwide, leading to famines in some regions. However, Yellowstone's potential super eruption could cause far greater and longer-lasting impacts on the global climate. The good news is that Yellowstone's potential super eruption might not happen anytime soon, and there is a possibility that the last eruption was the last. Volcanoes eventually die out, and if less heat enters from below, the magma chamber beneath Yellowstone could freeze and turn into a solid granite body. Additionally, the hotspot beneath Yellowstone is moving northeast, so it will eventually move out, and the supervolcano will presumably die out. Despite these positive possibilities, the thought of a super eruption is still terrifying. It's crucial to understand the impact of such an event and be prepared for the worst. Now share your thoughts about Yellowstone erupting in the comments section below.